I'm sorry, it's in Japanese. I just finished this presentation in Japanese, so I didn't change it. Well, it's something about how to say by combining EEG, EOG, and EMG to build up assistance system for the driver. Yeah, and it's a basic research. Well, my idea is that the relationship between humans and a car is like this. As a beginner, we know nothing about a car, but we try again and again, and we get feedback from a car. We know the performance of a car and how to say how to use it and get skilled, get grown up. Well, the problem is that human's ability can be extended, but a car cannot. Well, is a car's ability fitting the people's? For example, he's a beginner. Well, this car's max speed is about 500. It's too fast for a beginner. It's not a good idea. So I'm thinking a way that fitting them together, adaptive to each other. Well, and I think that the growing procedure is very interesting. Well, if we use such kind of car, well, Google car, well, it's not. I don't think it's a good idea to use such kind of machine, because people cannot get trained, cannot get more skill about how to drive. Well, about how to realize it, well, we have actually a lot of kind of by all informations. For example, well, at first, let me give you 5 factors when driving. The first one is attention, and how well can you concentrate? Can you concentrate on driving? And is the things happened different with what you thought? For example, you want to speed up, but what you touch is a stop, brake, something like that, and this one is about the smoothness of motion, or the order. For example, well, the action, well, is that in red order? Well, you move your hand at first, and after that, the foot. Well, and how actively you can get the visual information. This is the 5 factors I think are necessary for building up such kind of system. Well, how to measure that? How to? I mean, the 5 factors. How to evaluate? That is the problem. What I want to use is EEG, EMG, and eye tracker. Well, EEG is I don't know how to explain. We can understand it by brain wave, the signal from the brain. Well, it reflects your inner mentally status, well, something like that. And EMG, well, for example, when we move your muscle, well, we got some signal from that. And eye tracker is actually it's just the motion of your eye. Yeah. For example, we use eye tracker to check which point you are looking at. By combining these 3 kind of signals, I think I can evaluate the status of a human brain, or the emotion you're in. Okay. But there are some problems when dealing with such kind of problem. For example, signal processing. EOG. When we process EEG signal, it is always contaminated by EOG signal. I mean that because our eye motion can, our eye is always moving, and it generates a lot of, unnecessary potential. That potential affect all the signals you get from the surface of your brain. So it's a very, very difficult problem to solve. before building up such kind of system, what we must do is get rid of this potential caused by eye motion. Well, generally speaking, there are two kinds of methods to deal with this problem. The first one is, when analyzing EEG signal, the first one is to use some frequency domain power analysis. Well, just measure the strength of some band-filtered signal, for example, alpha wave, beta wave, gamma wave, of that. And another kind of method is denoise the EEG signal at first. For example, we separate the EEG signal and EOG signal. After that, we use some time sequence analysis to get some, for example, ERP, well, say, event-related potential. For example, if you're thinking about red, well, some signal like A comes up from a brain. If you're angry, well, it changes into B, like that. Well, the basic, most frequently used methods are shown here. Well, like linear regression, blind source separation, or with it. This is what I did during the last year. The first year of my PhD. It's about the pattern of eye motion when people seeing something. Well, this is a very simple example. We just draw a very, very simple artifactual, pattern. Well, and check how the people's eyes move when seeing such kind of figures. Well, this is artificial graphic, and this is the natural graphic, a flower here. When we change it into a natural figure, the pattern is also changed. And what is interesting is that when we're seeing a blank screen, and this, they are in the similar, they are in the similar pattern.
Which means?
Huh?
Which means?
Which means, what? I mean that, how to say? Well, when the figure becomes more complex, well, the distribution of the eye motion will also change.
Well, the entropy of the picture is different.
Entropy, yeah.
It can be a description of the situation.
Yeah.
Because this is organized and there's not so organized. So I meant that the entropy of the data is a little bit different.
Yeah. The entropy.
Makes sense?
Yeah. I know. And you can see the trace of eye motion in these three cases. Well, when the entropy becomes bigger, well, the trace of eye motion also changed. It changed a lot. Well, it's something like more, well, the field of view becomes wider. This is about the experiment I did for the EEG and the EOG separation. You get some problem when dealing such kind of problem. For example, if you want to use a regression method to deal with the EOG signal, well, something like how to say, the EOG signal affect the EEG signal a lot, as what I said. But actually, there is also a proportion, a little part of the EEG signal comes into the EOG signal. For example, if you're thinking about something, the potential, well, which is derived from the center of the brain, also goes here. So, generally speaking, the regression method is to calculate the slope and the intercept of the model. After that, you just subtract it from the original signal to get the original EEG signal. To get, or how to say, to predict the original EEG signal. But if your EOG signal contains some, if your EOG signal contains some EEG signal, after you subtract the EOG signal from the channels, you get the EEG signal. A part of the original EEG signal is also subtracted. Yeah. Oh, a little complex. I'm sorry, I don't know how to explain. So, what I did is such an experiment. Well, this experiment is for getting well, first let me introduce you what I did during this experiment. The subject look at the center of the screen at first. After that, the points around, well, one of the round points will be randomly selected and become red. It means that the subject should move his eye into the point, become red. Well, an eye jump motion. After that, jump back. Well, because this kind of eye motion will generate some small change to the, or small change or influence to the EEG signals. Well, we just want to know. I just want to know how it affects the EEG signal. Does it have some relationship with, for example, does it have something to do with direction or the amplitude? So I did such kind of experiment. I also make a experiment letting the subject see such kind of driving scenes in driving a car, and to measure how does, for example, how does his eye move and the EEG signal. Well, this is an example of the data segment. You can see, well, this is the blink part. A blink also affects the EEG signal a lot. Oh, like this. This is the eye motion. When you move your eye, well, your EEG signal will be affected like this. Well, you can see it's a very powerful noise source from this picture. Well, but eye motion is a little different with blinking. They're in different patterns. Well, this is what I got after using regression method to crack the signal. Well, we can see that the blink here is limited, but there is still many glitch in this area. It means that the eye motion is not eliminated well. This is a small video that. Yeah. Before regression, this is after regression. Well, correction by regression method. You can see two very powerful noise source here, but not here after correction. Well, now the blink is over, and the left part and the right part, they are similar. The similar means that when there is no blinking or no eye motion, they are all the same. Such kind of method doesn't change the original signal when no eye motion happens. Oh, as possible method, ICA can also be used, but to be honest, I'm not good at math, and this is a little difficult method for me. Another, the basic idea is that to decompose the original signal into many independent components. After that, we just see the components and judge which is noise, which is the original EEG signal. After that, for example, these two channels, they are noises. We just refill the data with all zero and reconstruct the signal. We got this. This signal will be trusted as a clean EEG signal, like that. But that is very difficult for a beginner to judge which is the noise signal, which is the something meaningful, for example, ERP. So yeah, I tried this kind of method and compared with the regression method, but I don't know, well, how to use it efficiently, correctly. So yeah, but anyway, such kind of method is very interesting because it's also a possible way to deal with such kind of problem. And what I'm doing, well, after compared the performance of these two algorithms, now I'm developing the new method, well, by using wavelet transform and eye tracking system. I think that with the redundant information of eye motion from eye tracker, we can also, how to say, I believe that we can use this kind of eye motion information or signals or whatever from an eye tracker to correct the electrical signal. So I just want to combine them together and try to develop a new, more stable, well, better algorithm for correction. Well, this would have dated up. This would have. I'm sorry, this is about.
Okay, question in the
Sure.
discussion.
I have a remark.
Yeah.
There was such a name I mentioned today, to some extent, Erika Sato.
Erika Sato.
She's a lady, very nice lady.
Mm.
And she was working with Yamaguchi Sensei in Tokyo Metropolitan Institute of Technology.
Mm-hmm.
And they were doing some research, relation, I mean, they had some cars, and she was observing the blinking of the human, and you know, the blinking of the human and responding to the red and right lights, and even she was doing something like how the human was paying attention to the red light when and the green line when she was closing. So I just felt that maybe it would be interesting to look to her research. It's a little bit old, but probably you can find this thing. She was Japanese, or she's Japanese lady, and I have no idea where she's working now, but it was Professor Yamaguchi's one part of the research, because he had a project about the cars. And also one thing that we visited 2 years ago with Mari Toyota, there was a very interesting slogan. The slogan was that every car is a robot.
Yeah, the car is robot.
Yeah, because I was very inspired with the first thing when you said that the car is not changing.
Yeah, the car. It doesn't change. Yeah.
Yeah, but it's not true.
It's not true.
It's not
Even
true.
after you have bought it.
No, because they are developing technologies which are, you buy a car and the car should adapt to you. Not you study a manual, but the car should adapt to you. And it's called also from Yamaguchi Sensei ideas called human-centric. So not that human should read the manual, but the machine should adapt to the human. So like today I sat into VW of Kaori and I was doing these things to fit myself. Maybe when I sat down, then everything should be to adapt to me.
Yeah.
So this is very also interesting concept.
Human-centered
Yeah.
is conception.
Yeah, because on the other side you can monitor, or as far as I feel, you can monitor the state of the emotion of the human, and you can say that good emotion is when everything is okay and the human is feeling fine. And the final remark is that I was 5 years ago. I was in one project proposal with Fiat.
Fiat.
The
Fiat.
Fiat was
A very big company.
yeah, and the Fiat was intending to do so-called intelligent seating. The main idea of intelligent seating was that they wanted to create an intelligent seat or seat in the car, which would able to monitor the human emotion and reflect the human emotion into some obstacles or obstacles about speeding and advices to the human. The car would be giving him relaxation music if he is very angry, or autonomously, or talk to him when he's getting sleep, and these things are very very interesting. However, the proposal was not accepted because of one thing, and that you are facing also, that you are not able to measure the frequencies because of the low frequencies. They are 5 to 12 hertz, or
Oh yeah.
this is correct, 5 to 12 hertz.
Yeah.
Yeah, of the EEG, and so that's a problem which would be very interesting to solve. And one of the reasons is that what I saw in the professor, what's the name of this professor who has the lab here for measuring the
Professor Natsume.
Natsume, yes.
Yeah.
Natsume Lab, I saw this, that they can have a Bluetooth, I don't know if...
Yeah, a portable
Yes.
measuring
Yeah, yeah.
machine.
But
like
you still have to have on the head.
Yeah.
It's not solving a problem, it's solving only transmission. So that will be very revolutionary if somebody can measure it in distant way. Then this would be very very.
Yeah, it's really a little embarrassed that actually what I wanted to say is something about the conception, what I mentioned at first, about this part, that is the final purpose of my research, but what I said during the presentation was the most part of my presentation is about signal processing and many boring things. Actually, this is my final purpose. Well, to make driving a very fun, very interesting thing
Yes.
for the driver. And another point is that I didn't mean that the car doesn't change. What I wanted to say is that after you bought it, how to say, a human's capability can be, extended by training, by using the car.
Yeah, I know what you're saying, but the adaptation of human is more difficult, like adaptation of the car. You can imagine that the car would be finding out who I am, that I am a very silent, I'm a very boring person, and would maybe download some application from the store and would adapt to me. If I am very radical, you know, like professor and so on, that they would download different application and from the store and would talk in different way to me or react different to me or giving me
But you can,
different.
so you can have only touch panel in your car and select some options like I want you to do like this, and the car doesn't need to learn anything, you know?
Well, like this one. Google car.
Yeah, but
Maybe,
this is something different because it doesn't have to adapt to
Yeah.
people, but to the
To the other car.
Yeah, adaptation. Yeah, adaptation.
Yeah, well, just what I'm saying is that all the machine will adapt.
To adapt.
And will adapt to environment, will adapt to the human, will adapt as a human are adapting many years.
Yeah.
So I think it will be a synergy of adaptation of the humans and machines. So that's what I believe, and be careful about Google. Because she was working in Google and she's very sensitive to Google.
but not with
I'm I'm really sorry about that. I didn't mean that.
You understood what I
Yeah.
But I think the Google car will be more safe than
More safe.
yeah.
But do you think it will be very comfortable for every person?
No, but I think I agree with her in this sense that it will be only unmanned cars that they will talk to each other, you know, cars, and so they will be more safe. But if you have one car which is without driver, a second car with driver, that will be a big problem.
It's like going in taxi. Yeah, it's like that. I like driving personally, but I don't know.
Yeah. Very interesting because you started the companion, right? So then you said that you think about the assistant next. The first step is to think about the companion. Second thing is to think about the assistance or assistive system. Okay. Third issue, I would like to propose it making a partner. Partner means okay, even if the person is a human being, right? We cooperate together. Okay. If it is too much adaptive in the machine side, okay, human getting raised. Okay. So then the level, even the partner, okay, encourage our individual activity, and then also have some educational perspective. Okay, I don't need to help here because she's working now, energetically. Okay, I just wait, or something like that. Okay, too much assistance is not good.
Yeah, I know
Okay.
you're saying that it should be a global good for a human. So the good for human is, for example, exercise. So or you know, so it's the global, the real fitness is the human comfort and health and ability to be healthy. So mentally and physically.
Yeah.
So from this point of view, for example, I cannot imagine that I would be not driving. I'm nervous when somebody else is driving. So I like to drive. I'm not sure if I would be very happy to sit in a car which would be driving itself.
From behavioral perspective, it's a personality that wants control.
Yes, yes. You got me. You got me. She is also likes to drive.
So the other aspect
I
was
also understand because man doesn't like being under control. Me too.
the other prospect we were talking about the cars is means actually the most difficult part is in the real situation, the measuring the signals. Even the measuring the signals is very difficult in a situation of the car. The second that he already explained, that computational part, performing the computation. I feel the better way can be is the adaptation on the based on behavior aspect of the human. So if a system can be developed that is more based on the behavioral aspect and memorize the behavioral aspect of the person who is using the car is the best way. Because even if we try to measure the signals, you know that there are a lot of mechanical vibration in the car.
Yeah. You can bring noise.
Yes, and a lot of noises that we even in electromagnetic waves are there. Because you know that in US and the big car companies Toyota and Ford, they even measure the electromagnetic emission of the car and they try to suppress it. So in that situation, on time computing the brain signal and getting the result in the situation of the car is really means that is what I. So is a more is if it can be if there is a system that can means it's a personalization of the car. It's my car. I use it often. So the car should know my behavior. So personalization of the car in that sense is the aspect that can be reached far beyond, rather than the aspect that based on the signal tracking. So that is what my belief means. During the discussion, that is what my understanding. So I feel if we develop that sense, maybe offline loading of the like my behavior personality. I have been judged on the EEG signals or EMG behavior, judged offline, and that characterization is uploaded in the system and used as for the system, but not in the online sense. Online sense that cannot be.
You
that
mean like
cannot
a table? That it will be
Yes.
table. If this, then this,
Yeah.
then this,
Yes.
then this.
Oh,
Then
yeah.
this.
more like offline learning of my behavior, or some online learning, but not on the basis of EEG. On the basis of EEG, if the system learns, it should be offline learning. And online learning is the behavior.
Yeah.
Like if I get into the car, I like music, so I push the button. So my car will know that the moment I open the door and sit on the car,
Yeah.
it's very easy to measure the sitting.
I understand it's very great, but you know the how to say the real world is very brutal. You know, I know what you want to say, but I also want to do that. But the fact is that I cannot get a very clean signal. That it's very noisy. That I don't know how to judge the humans, you know, mental state by these EEG signal. So it is very necessary to research such kind of method. Well, about how to separate the EOG or eliminate the noises. So
Yeah, but I think in any case, I think EEG and EOG are very important information.
Yeah.
they're very important.
You cannot skip this.
Okay.
Thank you very much. Yeah, okay, let's close
Thank you.
with the